Hello, this is Dr. David A. Gaitros, Department of Computer Science at Florida State University, and I'd like to welcome you to my undergraduate lecture series on selected topics in computer science. You can find these videos and others at my YouTube channel at the URL listed below, or you can simply go to YouTube and search using Gaitros and FSU as keywords. Now on to the lecture. I'm going to show you how the machine, the computer, accomplishes division. And we're going to do that using a 4-bit number rather than 32 bits. 32 bits was taking quite a while. This is the worksheet I use to actually illustrate it. For my students, I'll put a copy of this out there for you so you can actually look at it. So we want to divide 2 into 5, okay, which should yield an answer of 2 with a remainder of 1. So that's what we want to remember. The very first thing we do is we load the values into the appropriate registers. Okay, so the divisor, which is 2, goes over here, and you'll notice that we put it in the higher portion of the 2 register area. So we'll put that over here, 0, 0, 1, 0, and the dividend we're actually going to put over here, right justified in the remainder. Okay. Now the very first thing we're going to do is we're going to subtract the divisor from the remainder. Okay, so I'm going to show you this once. So we're going to put the remainder up here, which is 4, 0, 1, 0, 1. Okay, now we have the divisor. Now in order to subtract the divisor, we have to add it as a 2's complement number. If you don't know how to do 2's complement, I have a video on that, so go over that, and binary addition. That'd be very helpful too. So let's put the divisor over here. 2's complement, we reverse the digits, and then we add 1 to it. Alright, we'll carry the 1. Okay, then we put that over here, and then we add. So this is the answer that we have right here. That's our answer, and that's going to go right here. Put it down. 0. All right. So now we have some questions to answer. Okay, if the remainder is greater than 0, it is not, because that leftmost 1 right there tells us that it's a negative number, so it's less than 0. So if the remainder is less than 0, then we put the divisor back. In other words, we restore the remainder to what it was. So let's restore the remainder. Okay, we shift the quotient left and add a 0, or 1, and then we shift the divisor right. Okay, so that is step 1. And what we do is we repeat that process. Now what I'm going to do is I'm not actually going to go through this step again. We've seen this already, and you know how to do it. Practice doing this for each one of these steps. I'm going to fill in the answers to show you what it actually looks like. I have the answers in front of me. You can't see them, but I've already done this a couple of times. So what I'm going to do now is actually show you. Okay, so we're going to do the remainder minus the divisor again. And this step, that answer is 1, 1, okay, 0, 1, 0, 1, okay, and again we see that it's greater than 1. We restore the remainder to what it was before. Okay, the quotient is shift left and put a 0, and shift the divisor right. Okay, step 3, the remainder minus the remainder is, okay, and then it is 0, 1, okay, 1 right there tells us that this is a negative number. It is less than 0, so we restore our quotient to what it was before. We shift the quotient left and put a 0, and we shift the divisor right. Okay. Now then, this is where it gets interesting. Okay, on this step right here, step 4, what's going to happen is whenever we do our remainder minus the divisor, what we're going to come up with is we're going to come up with this answer. So this is actually greater than or equal to 0. So now what we're going to do is we're going to leave the remainder alone. Okay, we're going to leave it there. Okay, that's what we want. Then what we're going to do is we're actually going to shift the quotient left and add a 1. Okay, so we're going to take this number, we're going to shift it left, and we're going to add a 1 right there. Okay, and then we're going to shift the divisor right. All right, good. Now we know we've got the remainder. The remainder is what we want. It's 1 right there, but the quotient's not right yet. So what happens here on step 5, and it always goes through, for 4-bit answers, it always goes through 5 steps. For a 32-bit number, you go through 33. So we're going to do the remainder minus the divisor again, and the answer we're going to come up with there is all 1s. It is a negative number, which means that we restore the remainder to what it was before, which is this number, 1. We shift the quotient left, and we add a 0, okay, and then we shift the divisor right. All right, very good. And there are our answers, and it came out perfect. Okay, the answer is, the quotient is 2 with a remainder of 1. And that's how the machine actually does division. Practice this a couple times. It is very, very easy to make a mistake. You can understand each one of the steps and go through them precisely and make a 1-bit error, and it will throw the entire answer off. So it is a little tedious and time consuming, but it does take some practice. Hope this helps you out, and on to the next video.